Hi everyone. So with this example, we have a group of researchers want to predict the volume of trees using a single measurement. Data in the table on the right is given for the diameter in inches, the height in feet, and the volume in cubic feet for a random sample of 31 trees. Look at the information below and determine which variable is a better predictor for tree volume, diameter or height. So I'm using this example because I wanted you to see a little bit about what an output would look like if we were using a different form of technology. So I use StatCrunch to do this problem, but it should still all look familiar. So we're trying to figure out which will be a better predictor for volume, the diameter of a tree or the height of a tree. So looking at this first output here, we have that the response variable is volume, forgot my S, and the explanatory variable is diameter. And we have the linear regression model here, volume equals negative 36.9 plus 5 diameter. And we've got a sample size of 31. Here's the correlation coefficient. And so we can see that when we compare this with the model where we tried to use height to predict volume, we got a much lower correlation coefficient when we were looking at height. And we can really see it from the scatter plot as well. So looking at the scatter plot with the diameter, this shows a really strong linear correlation. All the dots are close together. We don't really have any outliers. It's positive and very linear in form. Whereas the scatter plot for height is much more spread out. There's still, somewhat of a linear form here, and the correlation coefficient is moderate. It's not awful, but it's also not nearly as good as using the diameter to predict the volume. So let's use this linear regression model to answer some questions. So the first was the explanatory variable. So kind of already did this. This would be the diameter. And what's the response variable? This would be the volume. Now we want to write the linear regression model. So I'm actually, instead of using y's and x's, since I have volume and diameter, I'm going to use v and d. So I have that the volume, and I'm going to write this in y equals mx plus b form. So I'm going to switch, I'm looking here, I'm going to switch this around so that it's in a form that I'm used to. So I'm going to have the volume, don't forget to put a little hat on there, and let's round to 2 decimal places. So 5.07 times the diameter minus 36.94. So there's our linear regression model. Let's interpret the slope. So the slope here is the number in front of our quote-unquote x value. So in this case, it's 5.07. Remember that this is the change in our y over change in the x. So we can always write this over 1. And this would be the change in the volume over the change in the diameter. And when we interpret the slope, we always want to start talking about our explanatory variable and then move to the response variable. So we would say, on average, for every 1 inch increase in the diameter, the volume increases by 5.07 cubic feet. All right, if we have a diameter of two trees where one is 14.5 and the other one is 12.6, by how much does the model predict that their volumes will differ? Well, if we subtract those, so if we take and subtract the 4.5 minus 10.6, we get 3.9. So we have a 3.9 increase in the diameter, which means that the volume will increase by, if we take this 3.9 and multiply it by our slope, we'll get 19.773 feet cubed. So when the diameter increases by 3.9 inches, the volume will increase by 19.773 cubic feet. Let's write and interpret the y-intercept. So remember we had v hat equal to 5.07d minus 36.94. The y-intercept is the constant. So in this case, the y-intercept is negative 36.94. So what does this mean? This means that when a tree has a diameter of 0, the volume is negative 36.94 feet cubed. Now, I don't even need to talk about extrapolation here because this straight just does not make any sense. And it's not just that we can't have a tree with a volume of 0 or a diameter of 0. We know that. But the volume definitely can't be a negative number. So this just doesn't make sense in the real world. And that's okay. That happens sometimes with the y-intercept. It doesn't mean that there's anything wrong with the model. Remember, the model looks at the data that's given. So this model is going to work basically with a diameter from about 8 to a diameter of about 21. What is the predicted volume for trees with a diameter of 17.5 inches? So this one's nice. You're just going to put in 17.5 for the diameter. So we'll get v hat is 5.07 times 17.5 minus 36.94, which is 51.825 feet cubed. Find and interpret the residual for a tree with a diameter of 16. So remember that the residual is the observed value minus the predicted value. So we need to find the observed value. That comes from our table. So when x equals 16, or when the diameter equals 16, the volume as observed is 38.3. So when x equals 16, y equals 38.3. We want to do the same thing for the predicted value, but now we're going to use our model. So now when x equals 16, we'll get y hat equal to 5.07 times 16 minus 36.94. And this will give us, I lost it, there it is, 44.22. Your observed and your predicted should be pretty close together. So if you ever get something where like the observed is 38 and the predicted is 5,261, there's probably something wrong. They should be pretty decently close together. So this means that the residual, I'm going to write it back over here, is going to be 38.3 minus 44.22, which will give a residual of negative 5.92. So what does that mean? The model overestimated the volume when the diameter was 16 by 505.92 cubic feet. All right, we'll do this example in the next video.